Hello everyone, welcome back to Pepcoding. So the question which we will talk about today is called abbreviation 1, and this time we will be solving it using bits. You've already done this question in the recursion module, so we'll now try a new method of doing this question. So I'll just repeat for you what we had to do in the question and then we will talk about the approach, okay? So over here you had a string, okay, and the string, let's say it's pep only. So for this, the length of the string is 3. You have to find out all of its abbreviations in the following manner. I'll just tell you what. Basically, let's say for 0 it is 0, 0, 0. Here we have 0, 0, 1. For 2 we have 0, 1, 0. For 3 we have 0, 1, 1. For 4 we have 1, 0, 0. For 5 we have 1, 0, 1. Here we have 1, 1, 0 and here we have triple 1. So the abbreviations which we'll need to find out will be PEP. Over here PE1, basically whenever you will get 0, you will print the corresponding character, and if you get 1, you will print a count, you will print the number but not the character. Here you will get P1P, here we will get P2, here we get 1EP, 1E1, 2P and 3. So this is what we have to print, okay. Now let's see how we will do this using bit manipulation. So when we are working with a string, right, over here we will continue with our string pep only. So when we have a string and we have to figure out the number of abbreviations which we need for it, it is simple. Let's say the length of string is n. Then the number of abbreviations which we will find out for it will be 2 raised to power n. Okay, so for example in this case, so I have the length of the string to be n over 3. So my abbreviations will be 8. And what 8? 0 to 7. I'll have, and for this I will write the binary representation. So 0, 0, 1, 1, 0, 0. Okay, now notice that over here we have the indexing as 0, 1 and 2. And over here we have the indexing as 0, 1 and 2, right? But we have to work with the string only. So we have to take this position of the string. We have to start from the 0th index of the string only. So this is what we have to take care of. Now the next thing is how we will print the output. So over here, see, to corresponding to this 0 is P. So I'll print P. Here also I have 0, so E. Here I have 0, so P. Over here I have 0, so P. I have 0, so E. Now I have 1. How will I deal with the ones? I am taking a variable named count and I am keeping it as 0. As soon as I will come across a 1, I will increase the value of count by 1 and not print this. Okay. Then I will move to the next position. Over here, the string is empty now. So what am I going to do? I will simply take this count, print it over here and make the count 0 again. Okay. Then over here I have count as 0. Now I have 0, so P. Then I have 1. So count will increase and become 1. Then I'll go to the next position. I come across 0. So I will see that count is greater than 0. Whenever after a 1 I come across a 0, I will always first check if count is 0 or greater than it. Since the count is greater than 0, first I will add this count. Then I will add the character corresponding to 0. Then I will make the count as 0. Next place is empty because the string is traversed. Then I come over here. It is 0, so I have P. Count was 0. Here I got 1, so count became 1. On the next position also count was 1, so count became 2. Over here we had 1, so count became 2. Then the string is empty now. So I will put this count over here and make count as 0. Okay. Then after that I have 4. So for 4, first position itself holds 1. So count becomes 1. Then I have a 0. So what will I do? First add the count, then the character, then make count as 0. then I have 0 again, so P. Similarly over here I had 0, over here it will become 1, then I have 0, so add the count, add the character, make count 0. Again I have 1, so count became 1. Now the string is over, so add the count and make it 0. Then I have 1 1 0, so count was 0. First count became 1 for this, then over here it became 2, then I got 0, so first add count, then the character, make count as 0. Then over here I had count as 0. Over here for this one it became 1, for this one it became 2, for this one it became 3. So after that the string is over, so we will put this count over here. So this is how we will get the output. Okay, now let us try to do this using code, and you will be able to understand it better because we'll keep on discussing it simultaneously. Okay, so over here I'll just make this full screen. Okay, now see, I need to work for the abbreviations. So we discussed that the number of abbreviations which we will take will be 2 raised to power length of string, right? In the case of PEP, the abbreviations was 2 raised to power 3. How do we find out 2 raised to power any number when we are using bit manipulation? By left shifting 1 by that number. So over here I have to find the power of 2, I have to find 2 to the power 3, so I will left shift 1 by 3. Originally 1 lies as this. Now these 3 will be removed from here and will be added here. This becomes 8, so I get 8 as my answer, and that is what I wanted. So since I need to move from 0 to 7, what will I do? For int I is equal to 0, I is less than 1, left shift string dot length and I plus plus, right? Now the next thing is that we need to work with the string pep. So over here I have the indexing 0, 1 and 2. So I need to work for this string indexing only. So I will take for int j is equal to 0, j is less than string dot length, j plus plus, and I'll find out the character every time. So character C is equal to str dot add j. Now see, when I'm working with any binary representation, let's suppose I'm working with 101, indexing over here is 0, 1 and 2, right? Now the problem is that we need to work with this bit first since it is corresponding to 0th index of the string. So how will I find this most extreme bit? Over here we'll have int b to be equal to string dot length minus 1 minus j, right? Now I need to check whether my bit is 0 or 1, that is whether it is on or off. So I will check using I and 1 left shifted by the bit is equal to 0, or is it not equal to 0, that is it is 1, right? So if it is equal to 0, then also I had two conditions, right? Either my count will come out to be 0 or count will be greater than 0. So over here I will initialize count, and I needed some place to add the characters, right, to create a string. So we will create a string over here. Let's name it S, and this will be small, right? So what will we do? We will check that if count equals to 0 or if it is greater than 0, right? So if it is 0, then what we will do? Simply to the string we will add the character, right? Otherwise, first we will need to add the count. So S plus equals to string count. Then we'll add the character and then we will make count as 0. And if the bit is 1, then we will simply add 1 to the count or increment count by 1. Now maybe even after reversing the entire string, we will have a condition where we will have the value of count greater than 0. So what will we do in that case? We will add that value of count to my string which we created. So s plus equals to string count, right? And then we will print our string. So cout s along with enter. Let's try to run this. Okay, so now we'll submit it. And all the test cases are getting passed. So that means that we have done the right code. I hope you understood the question as well as solution, right? We discussed about abbreviation 1 using bits. So thank you for watching the video. We will see each other the next time. Till then, please like, share and subscribe to the channel. Thank you.